equation of motion. The Hamiltonian, in general, it is a function of generalized coordinates qk, generalized momenta pk, and time t. So how can we express this one? So we can express Hamiltonian as a function of q1, qn, p1, p2, p so on pk, comma so on up to pn, and time t. So here h is a function of generalized coordinates, generalized momenta, and time t. So we can write the differential of h. So dh equals to sigma k dou h by dou qk dqk plus sigma k dou h by dou pk into dpk plus dou h by dou t into dt. That it is equation number 1. But as defined in the equation, we have an idea that h equals to sigma k pk into q dot k minus l. So as according to the definition of Hamiltonian equation, we have sigma k pk qk dot minus l. So we can let us see for this dh equals to sigma k. So it is in the form of u derivative v. So we can express derivative of pk into q dot k as sigma k q dot k dpk plus sigma k pk into qk dot. That means u derivative v plus v derivative u minus l derivative dl. So like this, we have expressed the equation, differential equation for this h. This is equation number 2. Also, L is a function of q1, q2, comma so on, comma up to qn, and q1 dot, q2 dot, so on, qk dot, comma so on, qn dot, comma t. Here L is a function of q, qk dot, and t. So dl can be expressed as sigma k dou L by dou qk into dqk plus sigma k into dou L by dou q dot k into dq dot k plus dou L by dou t into dt. This is the differential for L, because here L is a function of q1, q1 dot, and t. And if you see dou L by dou qk, it is again p dot k, and dou L by dou qk dot, which is pk. So we can replace these two terms with p dot k and pk respectively. So as I told you, p dot k means dou L by dou qk, pk equals to dou L by dou q dot k. We are replacing with these in this equation. So dl equals to sigma k dou L by dou qk means pk dot into dqk plus sigma k dou L by dou qk dot, which is pk, into dqk dot plus dou L by dou t into dt. So this is the equation number 3. Let us substitute equation number 3 in equation number 2, because this is dl. Already in equation 2 we have dl. So we can replace dl with this equation. So let us consider this equation. dh equals to, this one is same as it is, it remains, and dl, in the place of dl we can just replace with this equation number 3. So dh equals to, just we are replacing dl. So we have minus, here we have minus. So we will multiply this one with minus. So dh equals to sigma k q dot k dpk plus sigma k pk dqk dot minus sigma k pk dot into dqk, minus into plus minus sigma k pk dqk dot minus dou L by dou t into dt. We are multiplying this term with minus. Now dh equals to sigma k qk dot dpk minus sigma k pk dot dqk minus dou L by dou t into dt. Here in this equation, this negative term and this positive term get cancelled. So here pk dqk dot get cancelled, and here in this equation number 4 only the 3 terms remain. So qk dot dpk plus minus pk dot dqk, this term, and here dou L by dou t into dt, this term remains. Here positive term and negative term get cancelled here. Now let us compare the coefficients of dpk, dqk, and dt in equation number 1 and 4. So this is equation number 4. We have the coefficients of dpk, dqk, and dt. Let us compare the coefficients of these dqk, dpk, and dt with equation number 1 and 4. So see, equation number 1. Here also we have dqk, dpk, dt. Now let us compare these coefficients from equation number 1 and equation number 4. So if we compare the coefficients, we'll obtain q dot k equals to dou h by dou pk minus pk dot equals to dou h by dou qk minus dou l by dou t equals to dou h by dou t. So these are the equation number 5a, 5b, 5c. So equation number 5a, 5a and 5b. These equations are known as Hamilton's equations or Hamilton's canonical equation of motion. 5a and 5b, these two equations are known as Hamilton's equations or Hamilton's canonical equations of motion. These two equations we have obtained by comparing the quotients of dpk, dqk, dt from equation number 1 and equation number 4. So this procedure of describing the motion of the system by these equations is called Hamiltonian dynamics. So here we have described the motion of the system by these equations, and this procedure is nothing but Hamiltonian dynamics. So that's for k equals to 1, 2 and so on, comma n. So in all these are 2n first order differential equations, which are much easier to solve in comparison to the n second order differential equations in the Lagrangian dynamics. So it is clear from equation number 5b, if we see from equation number 5b, so it is clear that if any coordinate qk is cyclic, that means not contained in H, then so from 5b, if if any coordinate qk is cyclic, so what will happen? Dou H by dou qk becomes 0. So here, if it is not contained in coordinate qk, dou H by dou qk equals to 0. So if from equation number 5, if dou H by dou qk equals to 0 means minus pk dot equals to 0. Minus pk dot equals to 0. Why? Because dou H by dou qk it is 0 because the H does not contain in the coordinate qk. So pk dot equals to 0 or pk equals to pk dot equals to 0 or pk equals to constant in time. So for any cyclic coordinate which is corresponding conjugate momentum is constant of motion. So further from equation number 1 we have, so this is the equation number 1 already we have, and if you multiply this equation number 1 with dt, we'll obtain, so dh by dt equals to sigma k dou h by dou qk into dqk by dt plus sigma k dou h by dou pk dpk by dt plus dou h by dou t dt by dt. We are multiplying equation number, we are dividing equation number 1 with dt. So what will appear here? Dh by dt equals to sigma k dou h by dou qk. So here dqk by dt, which is nothing but q dot k plus sigma k dou h by dou pk dpk by dt, which is p dot k plus dou h by dou t. Here dt get cancelled. So this is the required equation number 7. Now let us substitute equation number 5 in equation number 7. Already we have equation number 5 means we have 5a, 5b, 5c. Here we have 5a, 5b, 5c. So we have these terms. We can replace these terms in equation number 7. Let us substitute 5 in equation number 7. That means qk dot and pk dot. We will obtain dh by dt is equals to sigma k dou h by dou qk. So qk dot means dou h by dou pk plus sigma k dou h by dou pk. P dot k means dou h by minus dou h by dou qk minus dou h by dou t means minus dou l by dou t, because these we are replacing from equation number 5. Now dh by dt equals to dou h by dou t equals to, if you see, so this is the negative term and this is the positive term. These two terms get cancelled. So here plus here we have negative sign. So dou h by dou pk, dou h by dou qk, negative term, dou h by dou qk, dou h by dou pk. So both are positive and negative terms. So these two terms get cancelled. So this term remained. So minus dou l by dou t. dh by dt equals to, or we can say dou h by dou t, which is equals to minus dou l by dou t. So this is equation number 8. So if the Lagrangian L and H does not depend on time, then dou L by dou t equals to minus dou H by dou t, which is equals to 0. If H does not depend on time, that means dou H by dou t or Lagrangian dual by 2t. These does not depend on time. So we can say which is the value equals to 0. So hence dH by dt equals to 0. So from this one, we see dH by dt equals to 0 or H is constant. So we are mainly interested in the conservative systems for which the T plus V equals to total energy E is a constant of motion. Already we have described in the earlier. So here this is the required Hamiltonian equation of motion. Thank you, children.